Okay, good afternoon, everybody. I am Ganesh Kumar with Alphaworkz. And before I get started, let me just get a sense of the audience here. How many of us are end customers? End customers, okay. And how many are partners, developers, etc.? Okay. About sort of 50-50, I guess. And I hope this talk is relevant to all of us. And how many amongst us are connected or service or are connected with the manufacturing space? Okay, super. And IoT, PLCs, connecting with equipment, getting machine data, is that relevant to most of us? Okay, at least some. Okay, let's see. So without much ado, a little bit of a background about Alphaworkz. Um, Let me start with that end of the slide. We are a group company. We own another company which is in the manufacturing space, and which is where we implemented ERP Next and Frappe over the last few years. And I personally have a background in IT, and I've run various IT companies, startups, and sold them, and so on. So Alphaworkz is where we incubate ideas, and more specifically ideas and technologies which would benefit SMEs like ourselves and also share it with the world. So it was started in 2010, and it has done projects and various kinds of products in various areas. And today we are looking to build various solutions on Frappe, which would benefit all of us. So let's recap. So this journey with Frappe and ERP Next is not new. Last year I gave a talk about how we implemented ERP Next on our shop floor. And we are a auto component manufacturer supplying to most OEs and in a process industry. And our journey is a little similar to I think Satish is the previous speaker's name, what he described. And like he said, while most companies have ERPs, getting data, the correct data of even stock in most companies, in my experience, is shaky. So if you don't have control over stock, what kind of planning can you do with an ERP? So we try to rectify that situation. And our real key performance indicator for the first phase of our project was, can we get the right inventory in different stages? And will the system inventory match what is on the shop floor on a real-time basis? And I'm happy to say that we are pretty much there, at least 95% there. And I would credit that to what we call smart screens, where we were able to push the data entry to the shop floor, where all the operators actually make entries into or interact with the ERP. Therefore, there is no lag between data being captured and it getting into the system. So there's no separate team of people doing that. And therefore, we were able to do a lot of things. And therefore, that means the interface they had to use was something that had to be really easy. And we used a lot of barcodes, like what Mr. Satish indicated, and a lot of things. And if you want more information, the previous year's talk is there on YouTube, and you can check it out. So, but then the next question was, what next? So what are we going to do in 2024? That was the first stage, where you get control over your operations and measure what is being produced accurately. The next is smart manufacturing. Can we get better, right? So when we say smart manufacturing, what is it? Is it IoT? And really, what are the benefits? We've all heard this term of Industry 4.0, smart manufacturing, IoT, so on for a few years now. And if you really do a general Google search or look at what various intelligent people have to say, these are some of the benefits that would be touted. But coming from a small and medium industry background, I would really question all of these things. I mean, these all sound fancy, but in real terms, what does it mean to me? And in our experience, the first thing I want my smart factory to do is avoid blunders. Or the Japanese term for it is pokayoke. How can you error-proof your operations? And we found, and we believe, that integrating your data, the ERP systems, and your equipment together can save a lot of time, money, and heartburn if done properly. So to give you an example, when a part has to be produced, there are several things that need to come together. One is the correct tool needs to be set up, the correct settings need to be made in the machine, and the correct raw material needs to come into the right place. And in a process industry like ours, and when we make hundreds of variants of products in a month, and we produce about close to 80 lakh components a month, a few times mistakes can happen. But then you can use the power of technology to ensure, if all of these are integrated, to ensure that these errors do not occur. And when an error occurs, if the first loss is the loss of the shift and the manpower resources, but then the wrong production can lead to other unintended consequences, sometimes even damaging the machine. So avoiding blunders is a huge benefit, practical benefit that we see immediately, and I believe a lot of other organizations can also see. The other is process reengineering. How can I rethink the process with data? And I will talk more about that and how we are doing that in our shop floor. So a typical shop floor usually has a lot of PLCs. Every equipment, most equipment will have what are called programmable logic controllers, where you are able to control right from the basic switching on, switching off to various functions of the machine. But unfortunately, most PLCs are silos. You will have to operate and deal with them on an individual basis. They are not networked and so on. So we all know the benefits of networking, but can we do that? It's not that solutions do not exist. This is an age-old industry. There are a lot of solutions, but it is not to the reach of most SMEs. You have SCADA systems, etc., and you're looking at really not just the money, but also the effort of maintenance and ongoing support is quite significant. So the whole endeavor here is to see, can we bring it the Frappe way so that we make it easy for people to adopt, implement, network, and derive the benefits of these things. So when I say this, this is also not just for customers. What we are really doing is building products which all partners could possibly use and implement for their customers. So this is our architecture of what smart manufacturing would possibly look like with Frappe. Right. This works? Yeah. So you have various equipment, workstations, as we know, and these workstations consist of machinery, and then you have PLCs associated with each one of them. And then you have HMIs, or human machine interface. Typically, you will file consoles on, say, CNC machines or various other things, etc. They are called HMIs. And what we are saying is, as long as there are standards which allow PLCs to connect to the network. So as long as you have a MODBUS TCP or a MODBUS TCP compliant PLC, you put it up on the network, and then we provide a box, which is a PLC Connect Smart Connect box, and it's not just equipment. You will have, as a proxy, I've given this energy meter bank here, because almost every organization will have energy meters, because there's no organization without electricity. And being able to mine information from devices such as energy meters, perhaps other sensors like environmental variables, temperature, humidity, other things, weather information, which could be relevant to different organizations, it's possible to integrate or connect that to this gateway, which then pushes it up to our ERP Next and Frappe in terms of data, and then there are two apps that we are publishing, which will again be open source, which is one to interface with the PLCs, and because the PLCs have a different language in terms of how they are configured, and it is done by experts and people in the know of the specific processes to determine which ports and which addresses deal with which signals and which operations. And we'll see a little bit of that in a demo. And then there's another app, which is the gravy stuff for all of us, which is, this will then be converted into an SDK, which then allows you to just build apps on Frappe which will allow you to control and log information from all these devices, be it PLCs, sensors, etc. And therefore, you could even have a situation where you build HMIs. Today, what we are doing is the typical console which you see, which is hard-coded into the PLC, is something we are pulling out of that and building on Frappe, and then still controlling the PLC, controlling and logging information from it. So this is the high-level framework of what we are trying to do. So what is PLC Smart Connect? It unifies the control and logging across devices across the shop floor. You can configure your PLCs using Frappe and use SDKs to create applications within Frappe. And for that, we provide these two apps. One that talks to the PLC and helps you configure it, and two, which gets embedded into your Frappe environment and allows you an easy interface to code on the basis of that. So what can you do, or what can you make? You can make interfaces for control and logging. You can create data loggers. You can create if this, then what kind of systems, wherein various triggers, alerts, basically monitor the system in various ways. And this allows you to create error-proof your operations, eliminate any lag between the shop floor and, see, one of the biggest challenges most organizations face, or at least we face, is there's a department which sets the standards, like, the settings for a machine based on various factors. And those things could change based on any drawing change, etc. But it is not necessary that it percolates to the shop floor immediately when you have written records, etc. So you could still have old settings going into the machine, even though the standard has been changed. Now, when you have all of this networked and going through Frappe, these kind of issues and this lag can be eliminated. Then predictive maintenance, because once you are able to log information, you can then define and do various things, ensure traceability, and basically unleash the power of IoT for the small and medium business in an easy way. So we're going to talk about a few implementation examples, specifically NEDA mixing. How much time is somebody? Okay, yeah. So let's talk about this. Let's talk with a live example. This is a NEDA, or we are a little bit of a backup. It's a process industry where we create various compounds, rubber compounds, which are then molded into different seals or parts, which are highly critical seals. Most cars in India and abroad would be using them. And if they fail, they are critical, because if they fail, it will be a safety issue or the vehicle will not run. So it is unacceptable in today's environment. Now, there's this machinery called a NEDA. What it does is essentially brings together, we put all the necessary ingredients or, chemicals and rubber and various items in the BOM into this NEDA, and then it mixes it and makes it a compound, which is then used for the next process. Now, the critical aspect of this, now the whole thing is when you're making 80 lakh or 8 million parts a month, it's about repeatability. It's not about doing it once, but doing it hundreds of times the right way in exactly the same way. So how can you ensure that there is no human error that creeps into it? So the two critical parameters in this are the timing and the mix sequence. You don't put everything in one shot. You have different items which are put at separate stages, and then they have to be mixed for a specific time. So how do you control that is what we're looking at. So what we did was we integrated the information from this. So this is a typical interface where they would scan the packets. So similar to the previous thing, where the packets or the items that need to be, this is the mix sequence that is shown out there. It would be scanned, and only if the right item is scanned will it allow the next process. And once the relevant items are scanned, it will open the gate, and then you can dump the items and start the process, and the right timing is achieved. Now, when you have all the information together, it is really very easy. This is not rocket science. But the real trick is getting that information in a way that can be consumed by your ERP instance or your Frappe, right? So that is really, and then being able to log and control and then manage this makes it a really useful solution for us. So we are able to ensure that there's really, and at the back end, there's really a doc type, which is where the data is saved, and then you have all the log information of what was the temperature it was mixed in, what was the, the timing of it, etc., etc., etc. So, when I spoke about the benefits of smart manufacturing, there were two things that I told you about. One was avoiding blunders, and the second was process reengineering. So how do we re-engineer process? So in the same example, and there's the reason I picked this example, one is you avoid blunder by ensuring that the right products or the item sequence and the right timing is maintained by integrating with your controllers. But then, if you look at it, we are able to now, because we have data, we are able, and we know what is happening inside the chamber, we can relook at the process in a whole new way. We can ask the question, why is there a specific timing sequence given? If I say something has to be mixed for 2 minutes, on what basis is that 2 minutes set? Ultimately, all of us would have mixed some dosa or wheat batter or something at home. It is the amount of energy that you're expending into the product. After some point, when the mixing has occurred, there'll be a plateauing of the current or the energy that is consumed. So once that is achieved, you know that the level of mixing has been achieved. So the timing is only a proxy for good mixing. You know on an average that if I mix it for 2 minutes, this is going to result in but we don't need to go by averages anymore. We can be very specific, saying that, once I have this level of energy expended or this level of energy consumed, then I can switch to the next stage of mixing. Now, what this does is two things. One, it ensures that every mix, because the actual timing of mixing can vary due to environmental factors, due to batch characteristics, etc. But then here I am ensuring that it is definitely meeting the standard of mixing that I expect. And two, I'm not wasting any energy at all. I stop it at the point that I need to. So now my process is being re-engineered to be far better than earlier, which could potentially save me both time and money, and also ensure that the product that I do is good every time. So this kind of process re-engineering is possible and makes real sense for us as small and medium manufacturers when these kinds of technologies come into the shop floor. So I'm going to move from use cases to specific PLC, the two apps that I spoke about. The first app is how do you configure this PLC? Okay, now I have settings in my PLC. There's a particular logic, generally ladder programming is done on them, where I have set as to how to control my machine, but then how do I bring it to my web interface? So we have this PLC config module where you can define your device and then set up tables like this for this is an intensive process which needs to be done by the person who is conversant with programming of PLCs or the operation of those PLCs, because they will know which addresses, what are the parameters that they pass, what are the controls that you want, so on and so forth. And we provide a very easy interface to be able to do that. And this is a one-time activity which you would do when you set up your PLCs. Now, once this is done both for, the previous screen was for MODBUS TCP, where you are able to put the machine into the PLC into the network. But then we also provide what is called MODBUS RTU connectivity, where you are not talking to the PLC, but the sensor directly on a different protocol. So both are supported. And more protocols will be added as we go along. So with this, you are able to configure, and all of this, as you can see, is the Frappe interface, and you are able to get the information into the gateway. Now, what happens next is more probably interesting to most developers here. So we'll just have a look at this video where you now have a Frappe Connect device put out there, and you can just pull that information from the configuration file that was already set up, right? And it pulls all the data. This is an example for you. And then you can create an SDK in one shot. And once that SDK is created, in a minute or two, you are then able to use it in your development environment. Where, for example, here, what is shown is how a motor is controlled. And you get complete documentation on how you can build your interfaces. So if you see right here, there are various parameters like, oops, sorry. I was trying to, yeah. So there are various parameters out here which can be configured. So now even a person who may not know anything about PLC configuration, so on and so forth, it becomes really relatively easy to understand and set up triggers or log information or control it based on specific client requirements. So you could build interfaces, data loggers, and all the other stuff that I had already spoken about in a very easy fashion. And this will be, there'll be a separate documentation section which will give you a full detail of what are the devices connected and what are the controls that can be established. So that's pretty much it. These are the two apps. They will be fully open source and available. One of them is already published, and this will be available by the end of the year for most of us to use. So thank you, and I hope this was useful.